perfectly fine. And out of the sudden, 2 times in the same week, I had meeting with my manager, and right at the beginning of the meeting, the computer crashes.
Talk about
So
time.
technology, it just perfectly runs fine. And she was waiting for me from like some PowerPoint, like some slides. Once I start presenting, I told her, you know what? I'm afraid you think I'm doing this on purpose or something, but I am not. So technology is not perfect, but we're here for. So back to my conversation. Because as I told you at the beginning of the course, the telecommunication piece of it is not all of it. Part of it is I give you advice on, what you're going to encounter when you go to the real professional life, engineering life. And for those who want to pursue like advanced studies, open your eyes to new topics. And that's why we're like talking about these presentations. Something that all of you need to understand is some machine learning, guys. The next, not for now per se, but in the next 4 to 5 years, machine learning will touch every single job. So you don't want to be like left out. Something to bear in mind. So please just focus on the security piece. And actually, a couple semesters, the only differentiation between the project, because much all the students did the same, like high quality work. That was the only differentiator was the firewall configuration. I did not deduct a lot of points. Don't go, deprive yourself from sleeping or something. But I deducted just a couple of points just to distinguish between those students who tried and those who did not. Okay, so please focus on that security piece. I want you to understand what firewall, when you open the configuration screen, what do you find? So that's why I'm to stress that the firewall thing here. Okay, so happy you guys are working on the project. Okay. Just project. I want please like everyone to do some OpNet. I want like 1 or 2 students to do the OpNet. Remember when I gave you the assignment, I told you like every other class I'll be talking like a few minutes about the project. So as much as you can, I want every student to talk about to do some OpNet. And at the final presentation to me for the project, I want each student clearly like what they did. Okay. And I don't like it when some like 4 students team and 3 do the old work or 2 and the other person or 2. It'd be just like how do you say, passive participants. Okay.
Okay.
So let's go ahead and start today's lecture. As I promised you last time, I'll be talking more, but I'm not going to draw anything. I'm just going to repeat last lecture. Not fully, okay, like very quickly, so we can proceed to layer 2, to talk about layer 2. First, before I start, recap, like summary in a few minutes. Anyone has a question about last lecture? Did you miss anything? Did you find something not adding up?
Just a quick question.
You said you have a question?
Yeah, is it okay if I ask?
Sure.
You said front-end developers are people who design application, and back-end developers are people who do application server. Can you just remind me what the differences are? Like the application, is that like...
So front end is something that the user interacts with. So that's like an application, the app that you download. Okay? So that's the GUI, like when you go to Apple Store or Google Play or something, you download an app. That's most likely created by front-end developers. Okay. And by the way, don't get stuck too much on the namings, because different companies or different industries or different countries or different regions even have different namings. But just under two goals of interact with us as network engineers. Have the I would call them front end for now. Could use user interface developers. It doesn't really matter. These folks that design app that you actually touch with your fingers, you move, you press buttons, you put your name, registration, you click a button to receive a call, to make a call, send a picture. That's the user interface developers. The back end, that's the heavy lifting. The back end, that's the server at the core. Don't really see it, but that's what makes your app work. I'll give you an example. You want to call. So you're going to get Susie's number. You're going to put Susie's number on your app made by the front end folks. You click or dial. It's going to happen. Dial command and the number you just put will be transmitted over the network that you just created, and it will reach the application server. The application server that has all these rules, it will check is Bob in good standing in terms of him paying his bills on time. Is he allowed to make the call? Can he use his current device? Like all these questions, rules will be written by the backend folks. Okay. Did I answer you?
Yes.
Help you understand? And normally, apps developed by Java, Swift, and these like very lightweight languages. Backend is like they still use C, C++, sometimes Java, of course, Python. But if you're looking for a language an easy language, just to make you, again, you're not going to be a developer unless, of course, you want to. But it's good to understand what you're doing. I would recommend Python. Like for my career, although I came from electrical engineering background, at some point I was put as application architecture. Application, that's software, or layer 7 architecture. So I would architect software piece. So you're not really, don't know how, I'm not a coder, okay? So I coded a lot during my PhD. With C, I wrote like hundreds or thousands of lines, but not a coder. Something I cannot really do hours a day.
Professor, you said which layer you did PhD on? You said you did one
PhD I did on layer 2. PhD I did on layer 2.
Oh, okay.
Yeah, I did my PhD on layer 2. I had to write C code. But basically, yeah. And in order to show this idea works, you can program it in a simulator, like NAS or UpNet or something like that. Of course, since it's a new idea, Net will not be supporting it. But you just created this idea. You have to go deep in UpNet and you code it. I stayed like 6 years and a half, almost 7 years, coding UpNet with C code. And of course, I did some MATLAB, and you do like looping functions, and it's just a lot of tedious work just to prove your idea works. And once you get decent results, you publish it. Once you get like few publications, then you can defend your dissertation. Okay? I'm talking about like how, why am I saying all this? I'm just trying to open your minds that when you go work, many times your work call will not really match your like pure electrical engineering background. I'm just trying to open your eyes to that. That's all. I'm just helping you. If you have some time, take a look at a couple of items like machine learning, Python, stuff like that. That will help you be more comfortable in your career. Okay, so let's go back to last time class. So now we want to create a service. The service could be an email, could be gaming, be anything. So first of all, you want to have applications, apps. You have to write app, like at least for OS, which is Apple and Android. Then once you write those apps, each app store has its own requirement to make sure that you're uploading actual app, not like downloading something bad is gonna steal people's money or information. Has certain standards, so you upload. Sometimes it's a lengthy process. Get your app approved. So the app will be uploaded. While you're creating the app, backend folks were building the brain of the service. Brain of the service, called application service.
Thank you.
Like when you talk on the phone, when you use cellular network, the brain is called TAS, Telephony Application Service. Server. Telephony Application Server. That's that's what you use right now. Like when I called you guys, or you dialed in with your phones, what you use? TAS, Telephony Application Server. Checks that, you can make a call, you're not roaming, or if you're roaming, you're paying a fee for roaming. But these are all the rules. You have two zones, or two areas. You have the untrusted, that's the internet, or the public domain. So either you say untrusted zone, internet, or public domain. The public domain, like where me and you guys are sitting, that's the public domain. You have your device, either a tablet, a phone, whatever, and you're roaming around the whole world, really. And then you have the trusted zone. Trusted zone, that's a data center, has a lot of security, physical security and cyber security. So in order for us, as users sitting in the untrusted domain, if you want to talk to the application server, never make device on the untrusted domain, like your phone or your tablet, talk directly to the application server. What we have to put in between?
Firewall?
Thank you. Firewall. You have to put firewall or firewalls. So you have three types of firewalls or three types of traffic in general. So the first thing when you get your app, do what? You register for the service. Name, your date of birth, whatever. Some applications do not really require anything besides username and password. Some other application, they even going to ask you for social security, a copy of your driver's license. If someone opens a crypto wallet, an app, create some cryptocurrency, or open some banking line, they may ask you for your driver's license picture. And they'll run background check on you. So it depends on what does the app do. Again, functionality of the app dictates what steps and what information should be collected and processed. So that's the visioning flow. Then now you're good. You paid your bill, your first bill. You have valid email. You have valid username and credentials. Blah blah blah. Now you want to make a call or send an email, whatever the service is doing. Or if like video gaming, now you want to go to the list and see who's playing that particular game online. You can connect with them and play in real time. It doesn't really matter what you do. Before you start actual connection, you have to do something called signaling. Okay? And actually signaling that happens with your phones, like with the 4G and the 5G, you have to do signaling. Because at the end of the day, cellular network is a service. The phones that you have in your hands, this is the service, guys. It follows the same procedure. You go buy the cell phone, you go to the store, and in order to get the SIM, you have to give your credit card, they run background check on you, make sure you haven't defaulted on any of your blah, blah, blah. That's close provisioning. When you want to make a call, that's first you start with signaling. Signaling, you're just checking for some mechanical aspects. Mechanical aspects like phone, up-to-date, not like an obsolete phone, or like everything, like the whole thing, okay? It keeps checking. Once it's happy, it will tell up and Ann, hey guys, both of you pass all my rules. Rule checking, you're good. Go ahead and communicate. It will open a third line. That's for data. And remember the circuit switching topic that we talked about? Also, one in Chicago, we have dedicated copper.
Yeah.
Yes, Professor.
So basically, what happens once you pass the signaling, you and the other person will have uninterrupted pipe or link, so you can exchange information, stuff like that. In ideal world, do not store information or a lot of information in the application server. You have to have like highly guarded, called database, where you put your information, your customer's information, date of birth, like all this wonderful information. Then you have some breakaways or gateways or converters or transformers or translators, whatever you want to call them. So now in this ecosystem, you talk certain language. So if you're doing VoIP, signaling being done by SIP, Session Initiation Protocol, and in the exchange media, we use RTP, Real-Time Protocol, or SRTP, Secure Real-Time Protocol. It used to be RTP, now it's SRTP. So in this ecosystem, you use SIP and RTP. Okay, your elements talk these languages. Now you want to break out to talk to someone who has a 4G. 4G talks SIP, that talks like some other protocol, the 7 or whatever. So that translator will convert the RTP to SS7, for instance. That will make you talk someone talking like using different handset, doesn't have the app. Or like not part of the service. Same thing with like PSTN. You can call someone from your app to your landline. You could upload in a chat between you and your friend on this app directly to your social media network. You click on it, it's like share to, and originally you have to download it to your native phone memory, then upload it. Uploading it directly from the chat, you need a gateway for that. Translator. Talked about redundancy. So this system, you have to have at least 2. And of course, the databases, they sync up together. So you have a database in New York, a database in California. If I register in New York, right away, the database in New York is like, hey, I just got a customer. His name is Joseph, blah, 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 his information. So if the data center in New York fails, what's going to happen? The database in California will have all your information. Okay? So basically, there's no interruption in the service whatsoever. It's like 100% running every time. So look, redundancy. So we talked about it when you ordered your equipment, servers or databases. Or database is just a server with high capacity memory server. It's basically you order them in pairs. So when we talked about hot, cold, hot, warm, you guys remember that conversation?
Yeah.
No? So basically, you have everything doubled up minimally. If you're talking about, if like you're highly profiting the system and you have like hundreds of people, or hundreds of users, maybe you want to not even only have just a pair, probably can have two pairs. And this is called high availability. This is basically it. I just need to explain how passwords are stored. We'll be done here. So, do you have any questions?
Professor?
No.
Yes.
The rule validator, it's part of the application server?
It's the application server.
Uh-huh.
It's the
Thank you.
application server. So, for instance, what would happen is the following. Joseph tries to make a call. I'll send the signaling. So the signaling will go to the application server. So the application server doesn't know who's Joseph because the application server does not really store any data, right? The application server will perform a query, database query. The database will ask the database, hey, give me Joseph's information. The database will reply with my information. So it will say, yes, Joseph has paid his bill. That's good. By the way, Joseph has this fancy feature to upload directly a picture in the chat to the social media network. Because these converters, are like, you have to pay extra for it. Okay? So it doesn't mean that you're chatting, you're giving the green pass to upload the picture. The application server is like, yes, give me his records. When he joined the server, when he subscribed, did he pay the extra money, get the benefit of using this or not? Okay, so the rule checker or validator is the application server, and it gets the information from the database. Did that answer your question?
Yes, thank you.
This is almost reminds me of a border checkpoint, for packets, going from.
Exactly. But by the way, you actually demystified it. It's all what I described, guys. It just makes sense, right?
Mm-hmm.
It makes sense. Like right now, one of my tasks, I'm working on the telephony application server. Okay, so for instance, one of the features that I have, try to call your friend Bob, and Bob does not answer. I'll go check in the database. Did Bob leave another number to forward his voicemail to? Or another number, like sometimes you dial 212 blah blah blah, it does not work. Find it's programmed to, if you call someone at work, after 5 o'clock they forward all their calls to their personal number. So there's two different numbers. So what happened? I check, see, is if the person has a rule configured for number forwarding. It's just as simple as that. Of course, when you're dealing with 10 customers, it's different than 1,000, and then you're dealing with 150 million. Since I mentioned scalability. So if you work for like a small company, planning system for a small company that like in order of the thousands of potential users, the total different ball game from designing something for on a national scale, like national scale we're talking about. Can you tell me why? What's the main differences actually?
I think maybe you have more resources. Like
I can hear you.
more resources, you have more resources. So
Yes, more resources. That's number two. But what's number one? What's the main challenge designing a hyperscale? I'll tell you that. Go. I'll tell it to you. Blay.
Repeat.
Blay. Right?
To repeat.
I cannot hear you. I'm sorry. Say that again, please.
To repeat.
Delay. The answer is delay. You know,
delay.
I'll tell you why, guys. Because if you have 50,000 customers and the application server introduces like 2 microseconds delay per customers, you still can manage it. But if you're servicing 20 million customers and each one will have like only 1 microsecond of delay for the processing, eventually you could clog up the system. So you have to serve all these subscribers simultaneously or in queues without impacting the system. I'll go back to the queuing theory. So now you understand why the queuing theory was so important? The stability. So the queuing theory, like how many you can serve, like the ice cream example. You guys remember the ice cream shop example?
Yeah.
That's why I asked you guys to understand that, because this is basically the basis of any network telecommunication design foundation. So you have to make sure that you can service customers without delay. Of course, you have to offer them, you have to make resources available to them. Okay, so let me talk about something good for you guys to know. So this is the database. Database, okay? So let me ask you something. When you do you create an email or a VoIP service or app, you have to do username and password, right?
Yeah.
Name on. So this is the password, okay? So where you store John 123 and Street 12 blah blah blah? Where you store these credentials? Application server or somewhere else?
Would it be the firewall?
No.
In the database?
Thank you, in the database. So, not really, but yes. So, basically, guys, you would put username, the database. But for good security practice, you never store a password. Never, ever store a password. Why? I'll show you. Or how. I'll tell you the why later, but what's the how? So the how is like this. This is called hash algorithm. I'm not going to examine you on this, guys, okay? It's something, I just want you to know it for free. So I don't want you to panic, like, oh, the professor is going to get this on the exam. But this particular piece for the passwords, don't worry about it in the exam. But just understand it for your own knowledge, okay? Relax and try to understand. Dash algorithm is just a mathematical function. So what we do, we put the password here. And the output will be like this. It's called digest or whatever. So for simplicity, like 347890. So what I store in the database, I store the hash. Never store passwords. So in the database, I store the username and the hash. So in case hackers break into the database, they will never know the passwords. They only know the hashes, which mean nothing. I'll show you why. And also the big breaches that you hear about in the 2 million social security, 1,000 blah, 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 because people, engineers stored the password here in the database and hackers stole the passwords. Did not follow good security practices. So let me show you this. So every time you try, so when you register for service, you put your username and there's a hash algorithm, and this that comes out, this gets stored, and this, your password gets discarded. Okay? So next time, if you want to log in, you have to input something here in order to get a matching result. So 347890 by itself is not going to benefit you, because what we need the input, not the output. So you need to input your actual password, and I see if the result will match what I have in the database or not. I not get you the 347890, and I tell you, hey, that's your password. Log me in. You guys understood or not?
So, like, basically, like you have some kind of algorithm that only works in one way. So, like, you can use the output.
Thank you. The hash is only one way. Although hackers try to reverse it and are successful somehow, but yes, for the original design, it only goes one way. So your password is like password 123. I insert it one way, and the output will be like 1234. 124, that's my hash. So the system is designed, if you only know the hash, it's not going to grant you access. You have to know the input of the hash. But
Is the cryptocurrency also acts this way?
I'm sorry, say that again.
The cryptocurrency also acts this way?
Cryptocurrency is a little bit different. You know, it uses blockchain and no, it uses blockchain. Show you something nice, guys. You'll like that. Let me just share that with you. This is the hash. Okay. That's a hash generator. So if you're gonna have your password as nice flower, so what are you gonna do? Generate the hash. Nice flower, that's the hash. You see? You guys see my screen, right?
Yes.
The letter hash. So that's password. So the system discards this password. Okay. And it gets this hash. So what's stored in the database, just the hash. Next time, if you don't have nice flower, you're not going to generate a matching hash, and you'll fail.
Professor,
MD. Yeah.
try to delete like the R only. See, I want to see like what kind of hash comes out.
You need to change something?
Just delete the last letter. Yeah, I want to see like the hash.
Yeah, so that's okay. So I love that question because the hash works like if you change only one letter, it will change the whole thing. I love that. So see, E76 ends with C0. Let's change one letter. Look at this and look how it's gonna totally did me. Oh, what happened?
That does look really different.
No. So let me try two examples again. Like hello, 123. Okay. Hello 123. That's the hash. It starts with F30 at 71. So instead of the 3, we're gonna write 4. See, the whole thing changed.
Hmm.
You see? So that's a very smart question actually. So yes. So hashes are very sensitive. So there's no way, I mean, there's a way, of course. You can reverse it. By design, you cannot reverse it. But hackers, actually, the MD5 I was showing you, hackers could already reverse it. So that's why we don't use MD5 anymore. But it's forget about.
Sorry, but if two persons have the same password, they have two different hashes?
It's the same hash. The hash doesn't really care whose password is it. As you saw in the example that I showed you, put X, Y, and Z, it will give you something. It's very mechanical.
But if
Have the
somebody,
same password, they will give the same hash.
but if hackers got your hashes, and why they cannot then get the password?
Because by design, you cannot revert to the hash. By design, you cannot reverse the hash. Hackers, they have limited success in reversing MD5 that I was showing you, but it's something called SHA-1 and 2. They really cannot reverse it. But by design, hashes are not reversible, are irreversible. Again, hackers, they're here to break the rules, break the design. Make sense? Or
Yes, thank you.
you're welcome.
Is
So
there,
that's something for you. Go ahead.
is there like one main company that generates these hash algorithms, or does each company have their own adaptation?
No.
to
It's not
guidelines?
about company. It's about standard. Okay. So you have MD5 that I was showing you. It was very strong until like 5-6 years ago. Then hackers found a way to reverse it. So hackers now, if something is stored in MD5, they can go to the database and reverse the whole thing, or 90%. Then came something called SHA-1, SHA-1. You can just Google it. SHA-1 is not that secure. Now what's secure is SHA-256. 256. So right now, if we design something, we have to make sure it's SHA-256.
This is a Bitcoin thing, yes.
What about Bitcoin? Bitcoin used like
I mean, they
lot of
kind of
hackers-
using this SHA-256 to encode the kind of their information something.
yes. So basically, those who do not know what Bitcoin consists of, so basically, yes, the hash here, the hash is a huge science by itself field. Basically, yeah, they hash the transaction date, quantity, people, identification, etc. And after they hash them, they insert them in a blockchain and they distribute it. So yeah, hash also is used in the blockchain in the cryptocurrency. Yes. But before now, most of you probably thought that when you have the email password or your school password, whatever, it gets stored as it is, right?
Yeah.
Ideally, it should never happen. So, okay. So, any questions before I proceed?
No.
The hash algorithm is in the application server, I'm guessing.
Yes. So, since you asked that question, that's why I said I could be talking about the design for 6-8 months straight. But the application server, guys, is not like one server. Okay? The application server is called complex, server complexes. Meaning what? It's not like a single element. Application server has like 10 elements. So one element of it could be the hash thingy. Another one could be like call forwarding module. Third thing could be whatever. So it's not a single server. It's a complex of servers. I don't want to tell you that before because I don't want to make things too complex for you. Yes, it's a complex of servers, and each single piece has different functionality. Okay?
Okay.
Okay. Okay. So let's talk about layer 2. So layer 2, some people call it data link layer. Personally, I like to call it media access control, MAC layer. Okay. Later on, when I describe it, you may change your mind to call it MAC layer. But again, it doesn't really matter what you call it, as long as you understand what it does and how it interacts or how it fits in the 7-layer stack. So basically, one of the most important things I want to emphasize on layer 2 that it only has limited visibility. What do I mean with limited visibility? As of course you guys know, each layer has its own languages, like protocols, information, identification. So layer 2, nodes have to be physically directly connected in order for this information to be exchanged. I'll give you an example. I'm sitting here in my apartment in New York. I'm connected to the Wi-Fi. And I have a couple other computers and laptops in the apartment. So we're all physically connected, right? The Wi-Fi hotspot and our place connected together. So from layer 2 perspective, all these devices in my apartment can see each other and interact with each other. But if we want to make a call to California, for instance, that would be with a VoIP call, okay? My traffic will go from the router here, the phone to the router, the gateway, to a core network, etc., to reach California. So the Wi-Fi router or access point, it knows everything about my phone. It was layer 2, of course. I'm talking about layer 2. The gateway at the corner of the street or the core, no one outside my apartment would know anything about my layer 2 parameters. And cannot even interact or talk to my layer 2. So layer 2 has local significance. It does not have global significance. So the friend I'm calling in California, their layer 2 has no idea about my layer 2. Okay? Because layer 2, again, local significance. Although layer 3, which is IP routing, is end-to-end. Because my device, they know how to go to California. So they're connected. So IP is something global. has a global outreach. Is that point clear, guys, or not?
Yes.
So layer 2 is only physically directly connected nodes. Let me show you this basically. So let me clear this. So basically, these are two networks. Okay. You have a gateway here, you have a gateway here, and you have users. Okay. So what happens here, the layer 2, these devices layer 2, they know each other. These devices layer 2, they know each other. This and this layer 2, they have no idea about each other. That's the first and the most important lesson that you have to understand 100% in layer 2. You get it?
Yes.
Okay. So let's do this. Yeah, let's go back to the slides. So the data link layer is concerned with what? Local delivery. Local delivery. That's what we just described. So data link frames do not cross boundaries. Example that I just showed you. You know, they never cross boundaries. So data link layer, or layer 2, it has two sublayers. You have the logical link control sublayer, and you have the media access control sublayer. The upper layer, the link control, used to be one of the identifying hallmarks of layer 2. But guess what? As the resources became cheaper and cheaper, the CPU, memory, etc., each layer has its own logical link control. So this feature, not really one of the identifiers or absolute identifiers in layer 2 anymore. You guys get it? What is the identifier? The bottom sublayer, the media access control. Because no other layer can perform this functionality, the MAC, media access control. What is media access control? So we're in a typical say college classroom. It has one wireless access point, and there are 20 of us. And each one of us wants connect to the internet. Like some of us want to send an email, others want to send blah blah blah. Like each one wants to do something with the internet. The rule of thumb, which follows the laws of physics, only one node and transmit at the same time. What? So the 10 of us, in order for us to reach the wireless access point or the Wi-Fi or hotspot or router, whatever you want to call it, only one person, only one, can reach that Wi-Fi router at any given time. If two of us try to transmit same time on the same frequency, the packets will collide. Okay? So layer 2 plays a crucial role here. Layer 2 controls who would access the medium first. This is media access control. I would say yes, John will access the medium first. Mary, then Bob. So it just creates an order instead of each one just try to do their own thing and crash happens. So everyone understands?
Yeah.
Yeah, so two very important things, layer 2 we talked about so far. First thing, it has local reach. They're physically directly connected nodes only can talk to each other and see each other, layer 2 perspective. If we're working in two different networks, layer 2 elements in one network that do not know anything about the layer 2 elements in the other network. Number 2, it regulates the process at which devices will access the service first. And really, this is applicable to 4G, 5G, everything. But guess what? You have a cell tower. And you have 2,000 phones. But the cell tower can only take 1,500 at a time. So who's the first 1,500 at the 2,000 that access the medium? That's the layer 2. So the layer 2, of course, every layer is important. So layer 1, of course, will provide the physical connectivity. Layer 2 will determine who can connect first, who can connect second, and for how long. Because something like Wi-Fi, layer 2 makes you connect on a packet basis. So the MAC algorithm or Groove algorithms will let you only send one packet. I'll show you, I have a very detailed example, and most likely that will be on the final as well, towards the end of this lecture. But I have like full understanding of everything before this. I'm saying it's coming, I'm saying like, this is one of the things I like to bring. So, they will only allow you for one packet. Some other services like cell phones, you do the signaling. Once you do the signaling, the media access control will grant you uninterrupted line. Not per packet basis. Okay, I'm talking about like macro level. Micro level still works like per packet. Okay. If you didn't understand the last sentence, no worry about it. So let's proceed. Any questions before I proceed?
No.
Okie dokie. So logical link control, we talked about it, perform the control aspects. the access control, the max sub-layer is for determining which users get to use medium first. So what are the link layer services? Again, as I just mentioned literally 5 minutes ago, that these happen on every single layer. So first thing is encapsulation. So if you want to transmit something, packet comes from layer 3, which is the IP routing layer, goes to layer 2, right? So layer 2 encapsulates the datagram, whatever is coming from the IP layer, adding its own header. And now we have a layer 2 datagram, or the layer 2 frame, or layer 2 packet, whatever you want to call it. Also, implement channel access shared medium. We talked about this. Physical addresses. Okay. So, how many addresses are there in the layer stack? Any knows? Any guess?
1.
A little more.
I know there is like a virtual address, but I don't know if it's in this
Say again,
layer.
what did you mean?
I say a virtual address.
Individual. Okay. Okay. So basically, we have 3 types of addresses. Okay. We have IP addresses. That's layer 3 addresses. And we have layer 2 addresses called the MAC addresses. And we have something called port numbers. Okay. The most common one that pretty much everyone knows, even non-engineers, is the IP address. Since we're talking about layer 2, we have to talk about the MAC address. But I'll talk a little bit about the IP and the port numbers. So we have 3 types of addresses, okay? So the IP addresses, they are dynamic. What do you mean dynamic? Dynamic in the sense that every time you plug your computer or your laptop or whatever, at home or at work or whatever, ISP, Internet Service Provider, leases you an IP address. It's leased. You don't own it. It's rented out to you. Only for a period of 24 hours. After the 24 hours, you may get the same IP address. You may get a different one. Not really. There's no rule, actually. Okay? IP addresses are changeable. But of course, the ISP, the Internet Service Provider, has to keep a logbook, who owned that or who used that IP address during this period. In case a fraudulent activity or illegal activity takes place originating from this IP address, they know who was in control of that IP address at that particular time. So the second type of addresses, they're called static IP address. So if some of you are entrepreneurs, and you go start building your company or something, remember the firewalls and the service that I showed you?
Yeah.
The 3 firewalls? So if you're talking about a big company, most likely these have fixed static IP addresses. If you go to the ISP, or if you're the ISP yourself, you'll assign permanent addresses, IP address. So anyone in the whole world knows it's like 1.2.3.4 that belongs to Joseph.com. I don't have to resolve the address every single time I jump on the internet. But you have to pay extra money for that. Okay.
Professor, quick question.
Yeah.
Having a static IP address, who like it benefits precisely? Like the
Benefits?
company? It benefits the
It
company.
benefits everyone. That's a very smart question. What's your name?
Muhammad Ahmed.
That's a very smart question. Hey guys, the mentality of an engineer, successful engineer, is to question things. You know, like why this is better, why this is not better. So who would benefit from a static IP? The answer is everyone. Why?
Easier.
It's easier to manage. So everyone in the whole world knows that if you want to connect to the VoIP app, it's 1.2.3.4. I'm talking about developers and stuff like that. Of course, if you have the app, it would happen in the background without you knowing anything as a user. Also, eliminate spoofing. So you as a user, you know you're connecting to the actual company. Someone is like, you guys know like, you know this phishing. For instance, let me clear this up. So, you know, like for instance, Chase.com, right? But some people fraudulently send you something like this, Chase.com. You guys see this or not?
Yeah.
Like, you know, whatever. Chase.com, something like that. So if you're in a hurry, you would think that's your original Chase.com, right? So, of course, if you go to the Chase.com, the DNS server will resolve with an IP address. So the DNS server, you give a Chase, you give your IP address. So if you have a static IP, it will make you comfortable that you know 100% that you're connected to the intended destination. You not just made a mistake in typing the URL or something like that. So it's easier for the user to verify that, yes, I'm actually connected to a legitimate server. It's better for the server or service provider to announce to the whole world, yes, this is my IP address. If you connect to some other IP address, I'm not responsible for any illegal transactions you will be committing. So basically, you are giving some assurance to everyone, yes, this is me. Okay? With this, I'm going to conclude the class today. If 5 minutes or a few minutes for questions, and we'll pick up the addressing next class. Questions, comments, requests?
Thank you.
Thank you.
Thank you,
You guys, if you don't have a question, so have a good night, and we'll continue next class. Take care.